Hello, this is Quads here. I am doing the worksheet on tangent lines, so you can find the PDF of the worksheet and the answers in the description, and I hope you find this video helpful. If you do, like and subscribe, you know the drill. So tangent lines, before we draw that, I'm just gonna, actually, you know what, let's draw it. Tangent lines are a pretty basic derivative topic. So if you remember in algebra, when you were finding a slope of a line, you used 2 points to find the slope. Well, in calculus, we're trying to do that with just 1 point. So if you look up here, you can see that 1 point on the slope of that tangent line. So we can find the slope of this function at just that point, instead of taking a line with 2 points on it. And that's like a pretty basic point of calculus. So a lot of half of what calculus is trying to find the slope at that 1 point. That's what a derivative is, the slope of a tangent line. So if you've been wondering to yourself, what is the meaning of calculus? Here's half your answer. So you can see up here the slope, that's supposed to be an equal sign. And remember, Emma's slope is the derivative at that point. So f prime of a, the derivative of f of x at point a, because here's point a comma f of a. If you remember, that's x comma y. Hang on, before we get into normal. So yeah, we're just trying to find the slope of this tangent line, and then that's a tangent line. And then coming out here, we have a normal line that's perpendicular to the tangent line. And it's basically the same thing, except the slope is the opposite reciprocal. If you remember, the difference between slopes or perpendicular lines, it's the only difference. So you might be asked to find the equation for a tangent line or a normal line. So I think we'll get started here with number 1. Oh, right, before that, we should note some of the basic things you're going to be looking for when you're doing these problems. My hand's really in the way right now. The things you need are the point, so this, and the slope. That's how you get the equation of the tangent line. If you remember the form of an equation, point-slope form, those are the two pieces you need. And the slope is the derivative, like I said before. So basically all you're doing is finding the point, taking the derivative at the point. Number 1 is a pretty basic one because you're already given the point, which is really great. So right there we have 2, 3 as our point. F of x equals y, x is 2, y is 3. And then the derivative at that point is going to be right here, f prime of 2 equals 5, also already given. We don't actually have to do any math, which is a beautiful thing. All we have to do is turn it into an equation. So on this one, we have 2, 3. The slope is 5, if I ever get around to writing it. Sorry, I'm slow. And then you just put that into point slope form, and this is for the tangent line, remember, so the slope is just f prime of 2. Yeah. So that's the equation of the tangent line. Add that in to be clear, because this one also asks for normal. Yeah, y minus 3 equals 5 times x minus 2. And then here you have your point, x, y, and then your slope. And now we're going to look for the normal line, which has the exact same point, because if you remember the picture from earlier, the normal line's coming out of the same place, it's just perpendicular. So we're keeping the same point, and then we're just doing the opposite reciprocal slope, so that slope would be -1/5. And so the equation is going to look almost the same, the only difference is the slope, so that's going to be y minus 3 equals -1/5 x minus 2. And remember to take the opposite reciprocal, stick a negative in front, and then 1 over the slope from 1 over f prime of x. because this is also slope, it's just a new slope. So if that's unclear, sorry. 1 over f prime of x. For this one, just doing another tangent line, he's given us the point. So we're going to go ahead and write in point is 0, 10. It's easy if you just like write them out, even if it's like given to you right there. Just go ahead and list them out. At least it helps me mentally organize it. And the slope, we're just taking f prime of x, which in this case is 0, because it's the slope at this point. The slope of the tangent line at this point. So just plug in 0 to that derivative, and you're going to get 3. It's a nice and simple one. And now we just put that into our point slope form. And we get y minus 10 equals 3 times x minus 0. Same thing. And then you can just go ahead and put it over in y equals mx plus b. You don't have to for it to be simplified. I guess that also depends on what your teacher wants, but both of them are valid forms of the equation. And then here, yeah, we have our point slope. This one, we're doing just a normal line. Earlier, we did the normal line after doing the tangent line. We just changed the slope. Same thing, even when the question doesn't ask for a tangent line. So we're literally just going to do the same thing. Find this point, find the slope of the tangent line first, find f prime of x, and then do the opposite reciprocal of that to get the normal line. So you don't need to put it into the tangent line equation form, but you still need the slope of the tangent line to then convert that into the slope of the normal line. It's the only difference. Same process until the end, just converting that slope. So we know that our x is 1, but he did not give us the y this time. So we're going to have to do f of 1, which in this case is just 2. 2 over 1 is 2. Also, you can go ahead and convert that into f of x equals 2x to the negative 1, because you're going to use that when we do the slope. Yeah, here we go. Because you want it in that form for power rule. And so yeah, here's just that, how we got 2 for that. Just plug in the 1. So now we're going to do the slope. So f prime of x is going to be, power rule, bring that down, negative 2x to the negative 2. And we'll plug in 1 to that to get the slope at that point, at that, the tangent line that goes through that point. And here we are just getting negative 2. So now we can put that into the equation. Can you all see this? Let's see. So this one, well, oh, my bad. First we have to turn the slope of the tangent line into the slope of the normal line. Forgot that the question asked for normal line, not tangent line. So we're not done with negative 2. We have to make it 1/2. And then now we can do the equation. I'll move my face. Oh, okay. And we got y minus 2. Remember that point is 1, 2. So 1, 2. And that slope of the normal line is 1/2. Yeah, and you can put that in point slope again. Okay, this one's just back to the tangent line equation, but we have to do a little trig because the point which it gave us is trig. So, yeah. I'm a big fan of boxing answers. I don't know about you guys, but it makes me feel like my work's a little more clear. But yeah, back to number 4. Our point is pi over 6, 1. our slope is f prime of pi over 6, slope at that point, slope of the tangent line at that point. I say that every time. I'm going to start trying to be a little more clear instead of just saying the slope, but the slope of the tangent line at that point, because that's really what we're looking for. F prime of pi over 6. Might want to review those trig derivatives. I know I forget those all the time. And it's helpful to draw yourself a little picture with the angle so you can get your sine of pi over 6 and your cosine of pi over 6. So I'm going to draw that picture. Fortunately, my hand's kind of bigger than the picture. You'll be able to see it in a second, but it's at the angle of pi over 6, and you'll see the point there so that we can do sine of pi over 6 and cosine of pi over 6. So yeah, the x point is root 3 over 2. Remember, cosine, we'll use the root 3 over 2, and for sine, it'll be 1/2. So 8 times 1/2 times the root 3 over 2. And you get 2 root 3. And so that's your slope of the tangent line at that point. So now we're going to plug in to our equation. We'll get y minus 1 equals 2 root 3 x minus pi over 6. And I realize that this almost looks like a negative and then another line. Like you can see a break there. It's not. That's just pi over 6. But that's probably clear at this point. And there we have our point, slope of tangent line at that point. Alright, on this next one, we are going to look for a point where the tangent line is horizontal. So if you remember horizontal lines, the slope is 0, which means the derivative at that point is 0. So we just have to find the point at which the derivative is 0. So we can take the derivative of f of x here, set it equal to 0, and then figure out what our point is from there. We'll solve for x, and then from there we plug that back in. Getting ahead of myself. See it as we go. So first, take that derivative, f prime of x, so we're going to have 2x plus 4. Remember the power rule? And then that's going to equal 0. And then we solve that. So x equals 2, negative 2. X equals negative 2, sorry. And now that we know x is negative 2, we say, what is y? That would be f of negative 2. So we plug that back into this original. We're going to put negative 2 in here, not into the derivative, because that would just give us 0. So negative 2 squared plus 4 times negative 2 minus 1. And I believe we get 5, negative 5. I'm off with my signs today. And now we have our point, which is negative 2 here, comma negative 5. And we already know that the slope is 0, but this one's actually not asking for an equation, it's just asking for the point. What point is the line horizontal? What point is the derivative? 0. So there's our point. And this one's also asking for a horizontal tangent line, but it's just looking for values of x. It's not even looking for the whole point. So yeah, once again, f prime of x equals 0. Did I say f of x equals 0 for this one? I definitely meant to say f prime of x. I don't remember what I said. Sorry if I said f of x. F prime of x equals 0. Once again, we got those trig derivatives, not my favorite. Maybe you like them. But make sure you memorize them. And cosine of x is going to have to be negative 1/2. So now we need to find all the angles at which, all the x values at which cosine of x, so yeah, that's an angle, is negative 1/2. And so you can see this triangle cosine is negative 1/2 here and here, so that's 2 pi over 3 and 4 pi over 3. So x is equal to both of those, but it's actually not just equal to those 2 points, it's equal to those an infinite amount of times. So we have this 2 pi times in here, because if you remember, 2 pi is a period, so every time it goes around the circle, it's going to be equal, it's going to be negative 1/2 there, negative 1/2 there, negative 1/2 there, negative 1/2 there, over and over. So it's really an infinite number of answers, so we use it in there. So now, let's see, I'm going to have to move my face again. We're still looking for what value of x, except for now, instead of the horizontal line telling us the slope is 0, it gave us 3. So it's kind of the opposite of earlier when it went ahead and gave us a point and then we had to get the slope. Now it's just giving us the slope, because remember, those are our 2 main goals. So now we get the x from that. Set f prime of x equal to 3, solve for x. Just to clarify that a little bit, I'll take out that middle tan slope, f prime of x part, so you can see it better. Forgive my hesitation there. I definitely had a brain fart as I was writing this, but I figured it out. So then we got 2e to the 2x equals 8. And remember that to the inverse of e to the 2x, you would take the ln of it. But before we can do that, we have to isolate the e to the 2x. So we have to divide by 2 on both sides. And now we can do the ln. So now we just get 2x is ln of 4. And you can just leave it like that, because you don't have to know that off the top of your head. This one is special. That point is not on the curve, so I'm going to do a little drawing, because I forgot to do it when I was writing. Let's see if this is a good drawing. We'll do it up here. I think there'll be room here. Here's our axis. That's not straight, I'm sorry. We're going to say this is our function. And the point 1, 12 is all the way up here. It is not on the function, on the curve like we've been doing. But we actually have 2 lines that are tangent to the function. That's ugly, I'm sorry. That meet at 1, 2. Yikes. So we have to get those 2 points to get the equations, because remember, each equation is point and a slope. So we want this point, this slope, this point, this slope. And the way we do that, we have a little trick, is we're going to find the slopes in 2 different ways, and we can use that to set them equal to each other, figure out what the x values are, then we can get the y, then we get the slope. So you'll see me do that if that does not make sense right now. But yes, there's my ugly drawing. Okay, let's see. I hope that did not get in the way of me writing. Oh no, what is happening? Sorry guys, technical difficulties. The drawing disappeared, but now you'll see me work it out. So, if you need to go back and take a screenshot of that, feel free. Technology is beautiful, but it's also difficult. So we're going to find the slope 2 different ways, and then set them equal, like I said. The first way is the calculus slope, which is the derivative, like we've been talking about. And that's just negative 2x. Nice and simple. F prime of x. Now we're going to find the algebra slope. So if you remember that, that's y2 minus y1 over x2 minus x1. So we need 2 points for that. The first one is 1, 12. But the second one is just x, f of x. Because remember, we're trying to solve for x by setting these two equations equal to each other, so we want x to be in it. So then you get this 9 minus x squared minus 12. That's f of x minus 12 over x minus 1. We know how to simplify that. And now we're going to set these two slopes equal to each other because they're the slope of the same line. They are equal to each other. We just found them in different ways, and that's going to allow us to solve for x. So first we have to cross multiply to get that fraction out of the way. We're trying to get this to a form where we can factor it to figure out what x is. And then we're going to just go ahead and distribute that negative 2x and then put it back all on the same side. You guys know how to do this. So it's equal to 0, so we can factor it. And we're going to get x is equal, we're going to get x is equal to negative 1 and 3. I'll write that in a second. Now that we know x, we did all of that just to figure out what x is, which is basically like what other problems gave us. And now we go back to the normal tangent line process. I realize using the word normal here is confusing because there's also normal lines, not the same normal. I just mean normal processes and like what we've been doing on the earlier problems. So we're actually gonna have to do it twice because there's two x's. So for the first one, we know x is negative 1, and so y is f of negative 1. And if you plug that back into the equation, you get the point 1, 8. And now we're going to go for the slope, which is f prime of negative 1. We already know that f prime of x is negative 2x, so it's just 2. And now we're going to do it with 3. F of 3 is 0. F prime of 3, negative 6. That's, again, negative 2 times 3. Can't really see it here anymore. And now we got the equation for that one. Same thing as we've been doing. Y minus 0, so you don't have to write it. Negative 6. X minus 3. You get your point and your slope. Okay, so we are on the last one. Number 9 is similar to number 8, where 0.01 is not on the curve. So if you remember the picture, we got 2 points, 2 equations that we're looking for basically. Of all lines tangent with the intercept of 0, 1. So, oh no, you can't see it. Okay, first we do the calc slope, f prime of x, and we got 2x minus 4. And then we do the algebra slope with our points 0, 1, and x, f of x. And then we go ahead and subtract x squared minus 4x plus 5 minus 1. It's f of x minus 1. And then just x on the bottom. And we can simplify that to x squared minus 4x plus 4 over x. And then after that, we'll set the calc slope and the algebra slope equal so that we can solve for x. I'm going to move my face up to the top. So we'll set those equal to each other, like last time, cross multiply to get rid of the fraction. This is me trying to decide how to write on paper. Never decide where to put things, so bear with me. This one is laid out slightly different than I did the one above, but same process. So we cross multiply that, and then we can put it all on one side. Alright, so set that equals 0, solve for x, we get plus or minus 2. Now we know we have 2 points, x is 2, x equals negative 2, that have tangent lines that pass through, where have the y-intercept 0, 1, like the question asked. And so now we need to find the equation for both of those lines. And so we'll start with negative 2. Our point is negative 2, comma, f of negative 2. So plug that into the equation up there, and we get 17. That's 4 plus 4 plus 5. 4 plus 8 plus 5. I'm not being smart right now. And then we get our slope, which we already have our f prime of x solved here. So we just plug negative 2 into that. And we get negative 8. And now we can do our equation for our tangent line the way we've been doing it. Y minus 17 equals negative 8. And then it'll be x plus 2 since it's a negative 2. And it's our final part of the problem for the final problem. Very exciting, bottom of the page. Sorry, I'm having trouble moving my page up. And now we're going to do the same thing, but with point x equals 2. So 2 comma f of 2. If you plug 2 into that, you get 4 minus 8 plus 5. So can't do that in my head right now. It's 1. And slope is going to be, you're going to plug a positive 2 into the 2x minus 4, so we'll get 0. And so our tangent line equation is pretty easy. And we just get y equals 1 because it's like y minus 1 equals 0 times x minus 2, so y minus 1 equals 0, so it's just y equals 1. Yeah, so that is the end of our tangent line worksheet, equations of tangent lines. The most fundamental thing to this aspect of calculus, I'm struggling with words, I'm sorry. Basically, remember point and slope when you're working on equations for tangent lines, and slope is the derivative. So, this worksheet included review for a lot of other subjects, like we had a little trig, some E's and ln's, power rule, some chain rule in there, all things you have to like still know, but the main thing to take away is when you're working on an equation for a tangent line or a normal line, you need the point and the slope. So, I hope this video is helpful. Remember that you can comment questions, and then we also have a Discord server in the description where you can put personal calculus questions or ACT questions, anything you need help on. And yeah, like and subscribe if these are helping you, and have a great day.